Section 2.4, Truth Tables, Conditional and Biconditional Statements, Video 2. In this video, we will cover the following objective: construct truth tables with two simple statements that include conditional and biconditional statements. Recall that an if and only if statement is called a biconditional statement. In logic, the statement P if and only if Q is represented using a double arrow. P double arrow Q. In a biconditional statement, P double arrow Q, it is implied that if P then Q and if Q then P are happening at the same time. Thus, an equivalent way to write the biconditional statement P if and only if Q is if P then Q and if Q then P. So that double arrow is implying that the conditional statement can go in either direction. The main goal of this video is to create a basic truth table for the biconditional statement P if and only if Q. We can use this equivalent way to represent that biconditional statement using the conjunction of two conditional statements in order to get that truth table that we're searching for. So we're going to make a truth table for this statement here. We will start with P and Q columns. We will label those the same way we have been doing, making sure that every combination of true and false is present in the table. Then we will need a column for if P then Q. We will also need a column for if Q then P. If P then Q is a conditional statement, and recall that conditional statements are only false when the antecedent, the if part, is true, and the consequent, the then part, is false. We have that case happening in the second row, so the conditional statement will be false overall in that case. The conditional statement will be true otherwise. Now we're creating a conditional statement the other way around, if Q then P. Now Q is the antecedent, the if part, and P is the consequent, the then part. And again, we're looking for the case where the antecedent is true and the consequent is false, because that is when the conditional statement is false overall. We see that happening in the third row. This will be true otherwise. Now we will form the conjunction between these conditional statements. And so recall that with a conjunction, an and statement, it will be true only in the case when both statements involved are true. We have that happening in the first row and in the last row. If one or both parts are false, then the conjunction is false overall. So since this is an equivalent way to write the biconditional statement P if and only if Q, we now know what the basic truth table for the biconditional statement looks like. So I'm just copying the truth values from the last column here. And this is the main point of this video, is to develop this basic truth table. So we have that repeated here, truth tables for biconditional statements. And notice that a rule of thumb to help us remember this table is that if the truth values, or if the individual statements involved have the same truth value, so in other words, if they are both true or both false, then the biconditional statement is true overall. If the simple statements involved have differing truth values, so one is true and the other is false, or one is false and the other is true, then the biconditional statement is false overall. We'll write this rule of thumb. If P and Q, and we don't have to, P and Q don't have to be the letters, by the way. We could use whatever letters we would like to represent the statements involved. But for the sake of this video, we're using P and Q. If P and Q have the same truth value, then the biconditional statement, P if and only if Q, is true. Otherwise, P if and only if Q is false. Let's practice with an example. Example 2. Given the statements P and Q, create truth tables for P if and only if not Q, and not Q if and only if P. Okay, so we'll start the table with a P and a Q column. And then for the first statement here, we're going to need a column for the negation of Q, so that then we'll be able to make the column for the overall statement, P if and only if not Q. To form the negation of Q, we will take the opposite truth values of the Q column. All right, P if and only if not Q. So we're putting a biconditional between P and not Q. And again, our rule of thumb up above says that if the truth values match, so either they're both true or they're both false, then the biconditional statement comes out true overall. Notice how that is happening in the second and third columns. Otherwise, the biconditional statement is false. All right, let's make the next truth table, which is negation of Q if and only if P. We'll start this table the same way we started the last one. Negation of Q if and only if P. So again, we're creating a biconditional statement between negation of Q and P. And again, recall from the rule of thumb, if the truth values of the statements involved match, then the statement will be true overall. The biconditional statement will be true overall. Otherwise, the biconditional statement is false. So this is how those values would end up. Now, if we compare the last columns here, we'll notice that those are the same. We have the same truth values in the same order. And this is providing evidence that when creating a biconditional statement, order does not matter. And that ends up actually being true. So P if and only if not Q is the same as not Q if and only if P. Recall with conditional statements, if-then statements, however, order does matter. But we see here with biconditional statements that order does not matter. That double arrow signifies that it can go in either direction, or that it does go in either direction. Example 3, given the statements P and Q, create a truth table for not Q or if not P, then Q. We'll start this the same way. And we've gone through in a different video why we set it up like this. Notice that P and Q are both being negated, so I would need to make columns for those. We're just taking the opposite truth values. All right, then I'm going to make a column for what is in parentheses, which is not if not P, then Q. So we're creating an if-then statement between not P and Q. With conditional statements, we're looking for a case where the antecedent is true and the consequent is false, because that's when the conditional statement is false overall. Notice that that is happening in the fourth row. That's the only case where this is happening, and so this will be true in all other cases. Lastly, we will make a column for the entire statement. Notice that we are creating a disjunction, an or statement, between not Q and the column we just created. Recall that or statements are true when one or both parts are true. Or statements are only false when both parts are false. And here I don't have a case where both parts are false, which means that this will be true in all cases. Just as a side note, if all final truth values are true for a statement, then that statement is called a tautology. We have one last example to cover in this video. Example 4. Given the statements P and Q, create a truth table for this statement here. So we will start this the same way. Notice that P and Q are both being negated within the statement, so I'm going to need to make columns for those. Again, when negating, we're taking the opposite truth values. All right, I'm going to work with the parentheses, the first set of parentheses, which is P or not Q. I'm going to try to write small so that we can fit all of this here. Or P or not Q. So we're forming a conjunction, or sorry, a disjunction, an or statement, between the P and the not Q columns. Or statements are false when both parts are false, only in that case. And so notice that that's happening in the third row. If one or both parts are true, then the disjunction is true overall. All right, now notice that we are negating what we just did. So we're negating the statement P or not Q. So we're going to take the opposite truth values as what we just had. So if I look at the previous column here, and I'm going to take the opposite of those truth values. All right, next I'm going to look at the second set of parentheses there. So that would be P, not P and not Q. So we're forming a conjunction between the not P and not Q columns. That's an and statement. And statements are only true when both parts are true. That is only happening in the fourth row. If one or both parts are false, then the and statement will be false overall. And that is happening in all the other spots. Now I can finally put this together. So we have the negation of the statement P or not Q, if and only if, not P and not Q. So we're creating a biconditional statement between those columns. And if we remember our rule of thumb, biconditional statements are true when both parts have the same truth value. So in the first row, we have both parts being false. In the second row, we have both parts being false. The biconditional statement will be true in those cases. In the third column and fourth column, the truth tables are different. They don't match. So the biconditional statement will be false overall in those cases. And those are the final truth values. This concludes example 4.